Welcome to another episode on my Arduino Yun with electronics and fischertechnik, motors and propeller. Last time I managed to get this motor being controlled by this potmeter by changing some coda and changing a wire, rewiring actually. So with everything connected to the oscilloscope, let's see if everything still works. And let's give it some input. And then it's immediately visible that I need to change the time base of the oscilloscope. And let's see for this and for this one. Now I need the motor to run. Is this enough? Funnily though, this potmeter circuit decreases the speed when turning clockwise, while this one has the same effect turning counterclockwise or anti-clockwise, whatever you call it. So now it is at fastest, this one, and I'm not quite happy with the signal on the scope, so I think I should change the signals a bit, but not quite sure. This is a bit better. I should actually raise this level a bit. So now it is a bit more clear. So now I am lowering it and now I am increasing it, and that is exactly the other way from this one. So while this is working, including of course the switches, the buttons that is, so I have to diminish this a bit, press the button, and that should reduce the speed and turning up, and that works. So now all my attempts have been successful in this. What is next? Well, I thought, since I have some space left here, to put on a nice RC circuit. I haven't been dealing with that for a while. So with the input from this wire going to this LED, which is controlled with or should be controlled with this LED anyway, or with this potmeter, and I should show it here. With this potmeter I'm able to control this and then also the new circuit. So let's see how that works out. Now before I realize that circuit, I have made a simulation setup in Scilab, and I hope this will work so that I actually do see something on this oscilloscope. So the idea is constant voltage of 5 volts, then a diode, which is actually this diode, and then a newly to be placed resistor of 800 ohms and a capacitor that I have scavenged from an old board and hopefully works. So let's see how this ends up in simulation. And that's the end of Scilab. So this actually means that I have to restart it. Not that much of a problem, but it's a bit of nuisance, and I'm glad I saved the whole stuff. So Exos, and then no, I don't. Recent file, and I have to open this one, and let's see if this is more stable this time. Nope, it's not. Then I go back to Scilab 5.5.2 and see how this works out. So once again, no, smaller. Open. And I want expos file, this one. Alright. Wiring looks a little bit different for some reason, but let's try anyway. Invalid index. Alright, so they are not compatible. That means that unfortunately I can't do it the way I like. And never a good thing to come to this conclusion. So what to do? Right, this and this one. Nope. So unfortunately, well, I also have the other program that I showed earlier. So it's still running, of course. From the electronic development applications, but I cannot simply or easily simulate that. I can only show you the schematics, but that I already showed you, and it basically looks like this, although this is not entirely accurate because this shows like an LED, shows like a diode and not an LED, which this actually is. So in that respect, I should redraw this in Scilab 5 and make an accurate schematics in the schematics application. So let's do that. I redrew the circuit and let's simulate now. So this is a diode, actually in real this LED, then a resistor of 400 ohms and a capacitor of 4.7 microfarad, voltage detector, oscilloscope and the timer. So let's simulate this, and oh wait, nice thing, how much is this? 5 volts plus 5 volts. So simulating and see where it ends. Minus 5 volts constant. That's a bit is that logical? Can't say really. Might be that I'm doing something wrong, but I don't think so. Anyway, it is a constant voltage. So then it is time to show the circuit drawing, and once again this is in GNU schematics, and although this is not entirely accurate because you don't do the plus to the ground. Anyway, this is the symbol for the LED, the real symbol. Then the American symbol for resistor. If you compare this to the resistor symbol here, this is the European version. And then the capacitor and a voltage sensor. So this is how it should look like, apart from this one. So with that, it is time to put the actual components on the breadboard, and to keep everything as should, this resistor will hook up to the LED, to this one. So taking care not to touch the blades of the propeller. Then here goes the LED and the resistor, of course. Then if you look at this capacitor, this is actually an electrolytic capacitor, which has a plus and a minus, and this side, this line, is actually the plus. So I have to put it like this, and be careful to not touch this one either. I hope it makes contact. And then as a last thing, I have an LED to make sure that I can see there's actually something going through it. And that's a a very tiny one. So this one should be like this, and then I need a jump wire to connect to the mass. And I have two mass lines. So either one is alright, and this one is long enough. So I figure yeah, don't touch the blades. And this is plus, so I need to put it like this. And then it should do something. Question is of course what, and that is all depending also on this potmeter. So let's check. So now it's time for some input and see if everything works alright. This one goes near again, so does this one, and some input, and that is clearly it needed some turning for this one to run. And now the big question is, how does everything work out? This works out well, although one thing is for sure, this is no light, this is the metallic top of the electrolytic capacitor. So you should be looking at light from here, and that is not doing a thing right now, to my surprise. So it looks like I have to fix a wire. And still it doesn't do anything. And where is... yeah, right. That is the point, a wiring problem. So now this LED is working, but will this LED be working? That's a very good question. So let me the potmeter can't be turned more to the left, so let me change this a bit. Alright. It is a bit odd. Does this have to do with the location of anything like a probe? It should be. But it looks like it's wiring. And now it works. And if I hold the wire, yeah, Right, there's a wiring problem, and as long as this wiring problem is there, this LED won't do a thing. Provided that the LED is still working correctly. But for that to check, I can always use another one that is proven to work correctly. So let's be certain and replace this one. See whatever happens. I want first this LED to work. And yes, then I also see right, let me move this one up here. See. That's a bit better. Does this one still work? Yes. And now the question is, does this one work? I thought it did for a moment, but who knows? Now I may have made a little thinking mistake. One thing is that this circuit, and to show you more correctly, this circuit has effect, no doubt. If you look on the internet, there are several examples. They look almost the same, with the distinction that there is a switch in between this one and this one, or this one and this one. However, I don't have such a switch in it, because the point is that it loads, keeps loading, and when you press the switch it unloads. So I have to put a switch in it. Another thing is that I am using not just a capacitor, and now I'm going to look for such a capacitor in here. Because this is an electrolytic capacitor, which is one with a plus and a minus, and this is the actual symbol I'm using, not this one. So if you look here, and this wire could then go, and then I say, alright, and this wire could go, and this is then the actual circuit, not with this one. It has a plus and a minus, and that's it. And most experiments have a common capacitor with no plus or minus, and that may explain why I am not directly seeing something, but I will put a switch in between in the first place and see whatever happens then. So let's move this, and then I'll move rest as well. But I have to be a bit careful taking everything out, and I will have to look for an ordinary capacitor, of course. So this one will go here, and then another point of concern is a button, and nicest is to have a break contact and not a make contact, and this is a make contact. So this one will go here, which is exactly right. Then this one will go from here to here. Again, the capacitor. Here. For now. And then some, oops, there goes. That one, and that is one. It's bent a little. Right. Let's keep it this way. Now it's certain. Have I everything? No, I do not, because I'm lacking an LED now, which is not good. Anyway, this is how things are built. See, this one lacked, and now I can put this one in right here. But now it's not loading anyway, so, and now you can see how it flashes. Let me turn the light away. So the circuit does work, though not really the way I like it. But that's it. That's a way of it to work. So, last part of this episode. To keep the schematics realistic, I added a make button, not a release button, as this is a make button as well. And I wanted to insert it into Xcos as well. However, the switch here, although it is a make switch, it has something extra that doesn't really make it a hand button, hand switch. So I'll leave that. Anyway, this certainly proves that this is nicely working. I can see how fast it works, but I need it to have input. So let me give it lots of input. And then see how this works out. Alright. Now the right side left side motor is should be working right now. Alright. Bit of a disappointment. Now it should go. Yes. And let's now see how this behaves. Alright, it still works. You barely see it now because the light is so lighting is bright. Now you can see it work. And yeah, it's too much light. And let's see, whenever the light goes out, it doesn't. Okay, that's a surprise, because this one should go on as well at some time. And then it's always a surprise to see when things work and when not. Right, anyway, that's it for now. Thank you for watching. If you like this video with the experiments, please subscribe to my channel if you haven't done so. Like this video, give it thumbs up. Follow me on Twitter and retweet and like. Follow me on Instagram and like. Please donate to keep the videos coming your way. More information, please see my website. And this is of course going to be continued, because I am not entirely satisfied with this circuit. Yeah, not entirely. Anyway, like I said, to be continued. Bye bye.